Welcome to another screencast for Advanced Java Programming at Portland State University. In this screencast, we'll continue our discussion of getting started with Java by focusing on source code management using Git and GitHub. Before we get started, I just wanted to point out that using Git and GitHub, strictly speaking, aren't required for the course. You can learn everything you need to know about Java, and you can do all of the programming assignments without using Git and GitHub. So if you'd rather skip this screencast, feel free to go right ahead. But I think you'll find that using Git for source code management will make it easier to move your source code between the machine you're developing on and the machine that I'll test it on. A software engineering best practice is to put your source code under revision control. So the whole idea is that you periodically commit the current state of your source code back to a repository. So no more copying off to another directory, back in the day backing it up to floppy disk or whatever. Instead, you check your code in to a system that lets you keep track of what your changes are, lets you do things like revert local changes. So let's say you go down a code path and you realize that, oh, this is the wrong thing, you want to back everything out. Source code management system will help with that. You won't be collaborating too much in this course, but as soon as you have multiple people contributing to a code base, source code management is essential. You want to make sure that the changes that you make don't interfere or conflict with the changes that someone else makes. And like I said, it also comes in handy when you want to copy your source code onto multiple machines, which is something that you want to do in the Advanced Java Programming course. For instance, you'll likely develop your code, your assignments, your projects on your local machine, but I'll be testing them on the machines the computer science department has. And so you'll want to make sure to test your code before on the computer science department's machines before submitting it. And source code management makes that transition easier. There's a popular tool for managing source code called Git. In Git, you commit source code to a repository. And when you want to get code from a repository, you clone it to a local copy on your machine. Git keeps track of all the changes that you've made to your source code so you can go back and review them. You can move code between repositories, for instance the one on your local machine and the one hosted centrally, by pushing and pulling code. We'll see exactly what all this means in a little bit. Git has a very powerful mechanism for what's called branching, which allows multiple changes, usually by multiple people, to be managed independently. If you want to start working with Git, you can visit this URL right here. Git has installers and packages for all the operating systems that Java Virtual Machine runs on. And it has really good documentation. So even though source code management might be a newer concept to you, Git is very well explained and really quite easy to use. I won't go into details because there are lots of good tutorials out there, both on the Git website and then all over the inner tubes. But I do recommend it for your local machine, and it is installed on all of the Portland State machines. There's a service called GitHub that hosts Git repositories. Has free hosting for open source projects that are out in the open and are public. However, it also has the ability to host private repositories where you can commit your code, but other people can't see it. And for your project assignments, that's what you're going to want. Luckily, students are eligible for a free micro plan, which I believe gives you up to 5 private repositories. So what I recommend that you do is that you store your code for this class on GitHub. Of course, do it in a private repository. And by the way, I believe Portland State, the CAT guys, also support Git. They probably have their own Git repositories. I just like using GitHub because it has a lot of other nice features, some of which I'll show you now. So if you want to learn more about Git and the benefits for students, you can go to this URL here. And so basically what you need to do to get your free micro plan is fill out a little form. Well, first create an account, and then fill out a form basically saying that you're a student, you're taking a Java course, and that you'd like to have a free micro plan. In my experience, it takes them a day or two to sort of turn around the request. I think they verify that you have a valid .edu email address, things like that. But then once you have it, you can use Git for your Git and GitHub for your source code, not worrying about if anyone else can see it. Now, there is some setup associated with Git. You need to create your account, but then also you need to manage your SSH keys so that you can easily log into GitHub and pull down code. I'm not going to go into the details of that here. You can read all about it. Here again, has really good documentation. I did put a couple of URLs that you can visit to find more information about that. So I'm going to assume that you guys do all of that on your own, get yourself set up with GitHub, but what I will go through is the following. We'll create a private repository for our source code, clone it to our local machine, and then we'll add our source code to it. We'll do a couple of things like exclude generated files that should not be committed, and we'll take a look at the integration that IntelliJ has for Git. It makes it really easy to use. We might take a little bit of a look at the command line stuff, but it's all nicely integrated. And speaking of GitHub, all of the example source code for this class is available on GitHub at that URL. Okay, let's dive into some details about working with Git and GitHub. So here's what we're going to do. First, we're going to log into GitHub and create a new private repository called Advanced Java, and this will store all of the code for your projects. Remember, it's a private repository, so no one else can see it. Then we'll go back to the local machine and clone the repository. That'll basically get a copy of the repository on the local machine. Then we'll add some source code from that student project that we were working on in a previous screencast to the repository, and we'll commit it, and we'll send it back to GitHub. Then we'll log into one of the Portland State machines and check out the code, clone it on that machine. So now we've got the code in two places. We'll make sure all of that works. Then we'll go back to our local copy, make some edits, and then commit them off to GitHub, and we'll see how all of that works. So anyway, that's the basic life cycle of working with Git and GitHub. So let's get started. Okay, you go to github.com. This is where you would create your account if you don't have one already. I do, so I will click sign in and enter my username and my password. Brings me to my home page. GitHub has lots of great documentation, makes it really easy to get started. But what I'm going to want to do is create a new repository. I'm going to call it Advanced Java. And I'm going to give it a description. Source code, oh, there it is, for Advanced Java programming. Really important here, I wanted to make it private. And remember, until you sign up for your free micro account, the private option won't be available to you. Now, I want to have my repository have some stuff in it, so I'll say yes, please initialize it with a README. And I want to specify what kind of gitignore. Now, gitignore is, .gitignore is a file that specifies regular expressions and patterns of files that should not be included in Git, ignored by Git. And for things like compiled source code, your .class files, your .jars, and then other generated artifacts, we'll see here in a minute that we'll put in the IntelliJ project files. All of those should be ignored. So I want the Java language one, and it's here someplace. I'm just going to type it into the filter. Oh, good. There it is. Hit return. So I think I'm all set. I'll create a repository. Okay. And this is what the repository looks like. By the way, This is a new UI. I think they just rolled it out a couple days ago. I'm sure by the time you're watching it, it's old hat. But for those of you who have used GitHub before, this might look a little different, but all the same stuff is still there. So what am I looking at here? For the time being, let's not pay attention to things like the branch. Let's just say that we have ourselves a repository called Advanced Java, and right now it's got two files in it. That gitignore file, we'll take a quick look at it. It says I'm going to ignore, I don't want to commit files that end with .class, .jar, .war, .ear. Don't worry about wars and ears. This is stuff that will not go into the in the repository, so Git won't even try to add it. Just go back here. And it also has this readme.md. GitHub supports a markup language called Markdown for putting together wiki pages and a readme. That's not really something that you'll use that much in the class, but they give you this readme.md file for free. Okay, cool. So I've set up my repository, but it doesn't have anything in it. I want to put my source code for my student project in there. So what I need to do is I need to clone that repository to a local copy on my desktop. And the way I do that is with the git clone command, and I need to give it a special URL. And that URL is down here. I'll scroll over here to the right. I mean, I can't even see it. It's kind of long, but I can copy it to the clipboard by clicking this. Okay, so now I'm going to go to my terminal window. And I'm going to say git clone, and then I'll paste in that URL. So this is basically saying, hey, go off to GitHub and get the Advanced Java repository. Now, I've already configured all of my SSH keys. If you haven't done that, you might see some problems, some confusion or an error message that says, oh, that you're not authorized to do this or can't recognize your key or whatever. Go back to that web page for configuring your keys. There are a couple of steps, and if you haven't done it before, it might be unfamiliar. But you'll be able to figure it out. It's pretty good stuff. Okay, so I've cloned my repository. And now I'm going to change into the directory. Now here on my local machine, I've got the README, and actually let's do a ls-a so we can see the hidden files. And I've got a couple of hidden files. I've got that gitignore file, and I've also something called .get. The .get directory contains a whole bunch of metadata and sort of the database of changes. All sorts of good stuff. I'm not going to go into details of that. There's lots of good resources on the web if you want to find all the hairy details. It's kind of interesting stuff, and you're computer science majors, and hopefully you have interest in that kind of thing. But it's outside the scope of this discussion right now. So cool. I've got my repository all set, and so now I want to move my source code in it. So I'm going to move my source code for the student project to right here. So now I've got README and I've got student. Okay, so I've moved it there, but I haven't told Git that it should do anything with it yet. And so there's a command called git status that tells you what changes you've made. And it's saying, I haven't made any changes, but there's this untracked file. There's this student directory. So I could use the git command line to add the files to Git, but I'd rather show off some of the features that IntelliJ has for working with Git. So I'm going to open up the IntelliJ project for the student project. That's student.ipr. And notice that when I open it up, it pops up this little green dialog saying unregistered Git root detected. So IntelliJ has figured out that Git is involved here someplace, but it's not exactly too sure how. So I'm going to click on Configure because I do want IntelliJ to know about Git. Okay, and here in this pink, might be salmon background, it's telling me that there's unregistered Git root, users David PSU Advanced Java. Well, that's where I have the clone, the checkout of my repository. I want that to be a Git root for this IntelliJ project, so I'll just click Add Root. Okay, and there's a whole bunch of options here that I'm not going to go into right now. Suffice it to say, we've told IntelliJ that, okay, here is the Git repository that I want you to associate with this project. So let's click OK. Now that I've associated Git root with IntelliJ, I get this little changes section down here to IntelliJ. And this is it tells me what changes I've made to my source code that aren't there yet in the in Git in revision control. So it's telling me that I have 5 unversioned files: pom.xml, the student IML, student IPR, student.java, and student test.java. Okay, well, all I want to put into my Git repository is the POM and the Java files. Those two IntelliJ files shouldn't be there. As a matter of fact, the IWS shouldn't be there either. In general, you don't want files that are generated from other files to be checked into version control. Something like a class file, a binary, or these project files. Each developer that contributes to the project should be able to generate it themselves. I know some people like to have their IDE files checked into version control, but I've found that that just makes things confusing, and there are better ways to get around that. Anyway, here again, kind of outside the scope of this discussion here. So what I want to do is I want to instruct IntelliJ. Actually, I really want to instruct Git to ignore those files. And so now we're going to go back to our git ignore file and edit that. So I don't think IntelliJ, because it's in the parent directory of student, I don't think I have access. I can't edit that file in .git ignore. Nope, no matches found. Oh, and by the way, to search for a file, I used the navigate to file, Shift Command N. So I can't edit git ignore here, at least not easily. I'll just go use vi here. So I'll say vi dot git ignore. Again, here are the files that are going to get ignored. I'm going to add a new section. So the hash is a comment, starts a new comment section. I'm going to say ignore IntelliJ project files. And so that's going to be anything .ipr, .iml, and then .iws. Okay, we'll save that file. Now when I go back to IntelliJ and I click this little refresh icon here, it now reads the .git ignore file and says, okay, those whatever it was, the IPR and the IML files aren't under revision control anymore. I won't report them as needing to be added as unversioned. So you might have noticed that there's now one file in this default change set. Each one of these little nodes in the tree, branches in the tree, are what are called change sets. So there is one file that's there by default. Interestingly enough, .git ignore isn't available in the project, but because of the way Git works, you can see it here. This is fine. Oh, one more thing to point out, files are color-coded in certain ways. So for instance, files that are in blue have been modified, meaning that the file is currently under version control, but the local copy is different from the one that's in the repository. Files that have not yet been added are in red, and I believe files that have not been changed are in green. Green means something else. We'll figure it out in a minute here. Okay. So I'm going to. We've made this change to git ignore. And you can actually view a bunch of stuff about it. If you right-click on it, you can commit it. You can show the diff. So you want to see the before and after changes. IntelliJ will let you see that easily. Gives you a nice side-by-side comparison. As you can see on the right, we've added some stuff. Oops. But what I really want to do is I want to, I've made the changes. I want the changes to be seen by other people, so I'm going to commit it. So I'm going to right-click and say commit change. Notice the icon here, this little green arrow with the VCS. You can also click the same icon over here to the left to commit your changes. So what this will do is this will basically put the modified file into the Git repository, so that well, it's there and its change history is there. So I'm going to say, and when you commit, you should also provide a comment saying what it is that you changed, so that you or somebody else who's working with your code base can can figure out why you made a change. I'm going to say ignore IntelliJ files. All sorts of options here, like, but I won't go into them now. And I'll say commit. We've got a couple options here. I'm just going to do commit for the time being. Okay. Excellent. And so committed it. So there are no more modified files. And you can look at the log here to see that here is the latest change that I made. You can also look at it from the command line now, so you can say git log, and here is the change that I just made. Okay, so that is what you do with modified files. These other three files are all new. So I'm going to select them, right-click, and say Add to VCS. I guess there's also a keyboard shortcut there. Okay, now they're scheduled to be added to Git. They're not there yet, though. I guess green is they've been added. That's right. Blue is modified, black is unmodified, green is added, red is not under version control. Hopefully, you're not colorblind. So I want to commit all three of these. I want to put all these three files into Git. And so I'm going to commit them, and I'm going to say added source code for a simple student Java project. Now, when I commit things, it just goes to the local repository, meaning that clone, that checkout that I made on my local machine. I want to push these all the way back to GitHub so that I can clone it on one of the Portland State machines. So here, in addition to commit, I want to say commit and push. Okay, it did a little code analysis and said, well, there were 3 warnings, and if you remember back, there are some unused variables. I'm going to live with those for now. But this is a good thing to do. Before you commit your code, before you share it with other people, make sure that there aren't any errors in it, make sure that there aren't embarrassing warnings, stuff like that. I don't want to review, I just want to go ahead and commit. Okay, and so that committed it to the local machine, and now it's asking me, hey, okay, do you want to, you told me to push it back, and push it all the way back to GitHub, which is the origin repository and the master branch of the origin repository. Here again, don't worry about these details right now. Over here on the right, it tells me which files are going to be pushed, or which ones were modified by this push. It consists of 2 commits. There was the one we just did, and there was the one we did a couple minutes ago. This all looks good, and so now I'm going to push it. Okay, cool. I've done this before. I pushed this repository before, so it didn't ask me for my password. It might prompt you for passwords and things like that, password for your key store or other such things. Okay, now it's told me that the push was successful. There are no local changes. This is all really well and good. So now what I want to do is I want to make a checkout of this source code. I want to clone that repository on the Portland state machines. And the reason I want to do this is because even though I can develop on my local machine and all that will work really awesomely, when I test your projects, I don't do it on my local machine. I do it on the Portland state machines. And so before you submit your assignment, I highly recommend that you take a couple minutes and make sure that your program runs well on the machines that I'm going to test it on. And so I usually test them on the Solaris machines. So I am going to SSH into them. Okay. And now make sure that I have Git on my path. And it's a reasonable version. Okay. So now I'm going to do that same get clone command. So that was git clone URL. It's on my clipboard. Oh, it's asking me for the passphrase for my RSA key. Okay. And so it needed to get my SSH key so that it could talk to the GitHub server. And now it checked out my repository that now includes the changes that I just committed. Okay. And so now I've got the same code. I can go and use Maven to build my project and make sure that everything still runs as expected. Okay, everything still seems to work. We'll do a quick check of the executable jar file. Target student.jar. Missing command line arguments. Okay, this is good. It looks like we've got looks like we've got everything working. We have all of the code both on my local machine and the remote machine. So we'll exit out of we'll walk away from the PSU machines for now, and we'll do a couple other things. Okay, now that we've added some files to our GitHub repository, and we've seen how to commit them to a local repository, push it out to GitHub, and then get those files into a checkout on one of the PSU machines. There's one other thing that I want to demonstrate. I want to show you guys, which is what it looks like to make changes to your project, commit those to Git and to GitHub, and then get them down on the or copy them over to the remote machine, to the PSU machine. So let's go back to the project assignment here. Okay, essentially what this project does is it takes some command line arguments like Dave Mail 3.64 algorithms, operating systems in Java, and then prints out a big string that describes that student, something like Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems in Java. He says this class is too much work. Okay, there's a lot to do here, a lot to think about. I just want to take a small step here. So what I think I'll do is I'll do some more command line validation. Previously, all of the command line validation we did was to issue a missing command line arguments error message when there are no command lines. Let's issue an error message when the gender is missing. So all you have is a name and no gender. So let's go back to IntelliJ. So we can look at the source code. We can go to student. We'll go down here to the main method. Okay, so when there's 0 arguments, we'll issue that message. I want to do a little test-driven development here. I'm going to write my test first, and I'll come back and make that test pass. So I'll go down to student test. And let's see here, what do I want? I want to test that, well, I could say invoking main with no arguments, but about only one argument prints missing gender to standard error. Okay, so only one argument prints missing gender. IntelliJ has nice spell checking, which is avoids lots of embarrassment when other people see your code. Okay, so we are going to sort of follow the same pattern here. We'll have a main method result, which is invoke main of our student class. Oops. Oh, bad tab complete. And now we want one. We want to give it one argument, so just Dave, and we'll assert that our result.getError contains string missing gender. And while we're at it, let's assert that the exit code equal to 1. This is kind of an interesting thing about unit tests. There are two sort of competing philosophies about how much assertion you should do in a unit test. Some people say, hey, listen, a unit test should only have one assertion in it. That is, you set up some data, you perform an operation, and you just assert one thing about it. I think it's okay to have more than one assertion. There's no real reason to have a separate, only one argument has exit code of 1. It seems a little, well, I don't know, a little overkill there. So I want to run my tests. So I'll run student test. I'll run the whole thing. Goes off, builds the project, runs it, and okay, the old ones pass. The new one is failing. Oh, something I didn't point out before. You'll probably notice that when I started typing, IntelliJ has this green bar over here. That indicates new code that was added. Actually, let me make a couple other changes first. Here I used the name only one argument prints missing gender to standard error. I didn't have like this one here, invoking main with no arguments. I kind of like that new naming pattern also. So I'm going to get rid of the whole invoking main with and just say no arguments. I mean, these method names are so long, and it's pretty obvious what this test is doing is invoking main. So they're just like that. And notice there's blue over here to the left. The blue means that I modified existing code as opposed to adding new code, and that's what you get the green over there. And notice that the color scheme is the same as the color scheme that's used to highlight file names, right? When I've got a file with modifications, and we can go and look at that by I do Alt F1 or Option F1 and say Project View. Over here on the left, it shows me that student test, and student test is in blue, where student is in black. Oh yeah, and this whole background's green because something's been modified there. Anyway, pretty colors. Okay, back to my assertion error. It's it's saying that certainly enough, this guy is failing. That assertion right there is failing because it was expecting a string that contains missing gender, but instead got an empty string. So let's go back to the main method and fix that. So if args.length equals 1, we want to say system.error print line missing gender. do that. We'll rerun our tests. Yep, now it's failing for another reason. This assertion's failing because the exit code it expected to equal 1, but it was null. Okay, let's go back and change that. System.exit 1. Rerun. Everybody's green. Good stuff. Okay, I've got passing unit tests. I just added a little increment of functionality. I want to check them in before I check it in. I should make sure that it works from the command line because you know, when I test your code, I run it from the command line. I don't run it from IntelliJ. So it's probably a good idea to do a maven clean and a maven package. Clean will delete all of the artifacts, and then package will compile your code, run your unit tests, and assemble the jar file. Build success. Everybody was happy. I'm just going to scroll up real quick and see that yes, there were 3 tests that were run. So I got my new one. I'm just going to do a quick spot check of the executable jar file. See, with no arguments, missing command line arguments, and if I just say Dave, missing gender. This is looking really good. Okay, so I'm at a stable point, and I want to make a checkpoint by committing my code off to GitHub. So I'll go back to IntelliJ, and I'll look at my changes. Sure enough, it's got 2 changes. If I want, I can go review those changes by saying show diff. And so I can do a side-by-side comparison of what's changed. This is all the stuff that I expect. Okay, this is well and good. So now I want to commit them. So I'm going to say added error message when the gender is missing from the command line. Okay. I'll just do a commit and push because now I want to make sure that it still works on the PSU machines too. Again, it's some of those 3 warnings, the same 3 warnings before. This is cool. And by the way, if I don't want to see this anymore, I can just unclick the perform code analysis checkbox, which maybe I should do, but anyway. Commit it off. It wants to push it. Yep, this is what I want you to push. You can even see the diff here. That's kind of neat. So anyway, you can get a diff from this view also. Push that off to GitHub. Okay, no more local changes. Now let's go back to the Portland state machine. Now this code doesn't have the changes yet. So what I want to do is, in order to get the changes from GitHub, I do a get, not a push, but a pull. Oh, it's asking me for my... Cool. And so what did it do? It went and got the changes from GitHub and merged them into my local files. And it told me that I had something called a fast forward, and it's a Git thing. But it basically told me that, listen, I got some changes for student.java, some changes for student-test.java. Everything was nice and clean. So here on the PSU machine, I'll also do a maven clean and a maven package just to make sure that everything builds over here. You never know when you've maybe forgotten to add a file or something else got messed up. Maybe you had some local changes on the PSU machine. So it's just good practice to do a maven clean and a maven package before you run. It's downloading all sorts of stuff. Okay, successful build. Let's go just again double check that, yep, we have 3 tests that have run. And then I will, once again, test the executable jar. Command line arguments, Dave, missing gender. Awesome. Okay, this is good. I've committed all this stuff to GitHub, and you can view your changes up on the GitHub website. So if I go back to my repository page and I reload it, you'll see that now we have information about the change that have made. This has been the last change that we made to it, and now you can browse the changes that you made. As a matter of fact, you can even comment on them. This is probably not something you'll be doing for your own code, but you can imagine if you were sharing code with someone else, you can then go in and say, hey, this error message should be localizable, meaning that localizable, so that we can translate it into a different language. Stuff like that. Anyway, GitHub, lots of goodness here, lots of stuff for you to learn about. I think this is all that I want to tell you about today. So, thanks for listening, and in our next screencast, we'll continue building out our student application. Thanks.